Hi students, once again I welcome you all to my channel Abrar sir classes. ಇವತ್ತು ನಾವು current electricity chapter ಇನ KCET 2025 previous year questions solve ಮಾಡೋಣಪ್ಪ. I will teach you how to solve in just 45 seconds. Okay, this is the first problem. What it is saying, in the following circuit the terminal voltage across the cell. As soon as you see this one, first you try to calculate the value of I. Okay, because this is a positive terminal, this is a negative terminal. I is equal to what? Total voltage by total resistance. 2 divided by 3.9 plus of 0.1. ಎಷ್ಟಾಗುತ್ತಪ್ಪ ಇದು? 2 by 4 ಆಗುತ್ತೆ. That is equal to 0.5 amperes. I is equal to 0.5 amperes of current is flowing. Okay, what is meant by terminal voltage? Terminal potential difference he is asking. Okay, let us say this is A and this is B. Okay, he is asking what? Terminal potential difference. Andre VA minus VB. Andre V ಅಂತ ಇಟ್ಕೊಳ್ಳೋಣ. Okay, I will call this as V is equal to how much? Okay, this is 2, and how the current is flowing? Current is flowing like this, right? Okay, current is flowing like this. So this will be what? Plus, and this will be what? Minus. If you move from A to B, this we have seen in the previous videos also. If I move from A to B, what I am getting? Plus 2, right? That I have written here, plus 2. And if I move further, minus of 0.1 into how much? 0.1 into I. 0.1 into I. That is V is equal to terminal potential difference is equal to 2 minus of 0.1 into 0.5. That is nothing but 2 minus of 0.05. That is equal to 1.95 volts is the right answer. 1.95 volts is the right answer. See, okay. First, what you have to calculate? Current I, and then you can calculate the terminal potential difference. Okay, across the cell is 1.95. Hope you understood this. We'll move to the next problem. Okay, pa. Next, what it is saying? Two cells of EMFs E1 and E2. This we have learned in case of what? Millman's theorem. How to write E equivalent? E equivalent is nothing but sigma E by R divided by sigma 1 by R. Okay, istappa E1 by R1. Okay, plus of E2 by R2. Right, and then what? Divided by 1 by R1 plus of 1 by R2. Right, E equivalent is equal to, okay, if I simplify this one, what I can write? E1 R2 plus E2 R1 divided by R1 plus R2 ಆಗುತ್ತೆ. Okay, now this value lies between E1 and E1 and E2, and it will be, this value lies between E1 and E2, and E equivalent is nearer to what? The lesser value is nearer what? E1, which is because here E1 is lesser. For example, okay, so this is the right answer. We came to know that E equivalent will be what? Will be lying between E1 and E2, but it will be nearer to what? Nearer to E1, lesser value. For example, if I take E1 10 ohms ಅಂತ ಇಟ್ಕೊಳ್ಳೋಣ. Okay, R1 10 ohm, E2 20 volts ಅಂತ ಇಟ್ಕೊಳ್ಳೋಣ. Because why? Because E2 is greater than E1. R2 is 20 ohm ಅಂತ ಇಟ್ಕೊಳ್ಳೋಣ. Okay, how much equivalent will be? Use this formula. E1 ಅಂದ್ರೆ 10. Okay, 10 into R2 ಅಂದ್ರೆ ಎಷ್ಟಪ್ಪ? 20. Okay, plus of E2 ಅಂದ್ರೆ ಎಷ್ಟು? 20 into R1 ಅಂದ್ರೆ ಎಷ್ಟು? 10 divided by 10 plus of 20. ಇದು ಎಷ್ಟಾಗುತ್ತಪ್ಪ? ಇದು 200 plus 200 400. Okay, 400 by 30 ಅಂದರೆ ಎಷ್ಟಾಗುತ್ತೆ? 0 0 ಕ್ಯಾನ್ಸಲ್ ಆಗುತ್ತೆ. ಅಪ್ರಾಕ್ಸಿಮೇಟ್ಲಿ 13.33 volts ಆಗುತ್ತೆ ಇದು. Right, 13.33, which is lying between what? Nearer to what? E1, which is nearer to E1, and it is lying between what? E1 and E2. Lying between E1 and E2. Hope you understood. We'll see the next problem. Now the variations of resistivity. Okay, the variations of resistivity. We know that in case of in case of metals, ಏನಾಗುತ್ತೆ, what happens, where alpha is what, positive, where alpha is positive. In case of alloy, okay, in case of alloy is approximately equal to 0, okay, very small irutte, very small irutte. In case of semiconductor, okay, to make you understand very clearly, I am telling, in case of semiconductor ಏನಾಗುತ್ತೆ, in case of semiconductor alpha is what, negative, temperature coefficient of resistance alpha is negative irutte, okay. When temperature increases, when temperature increases, in case of metals ಏನಾಗುತ್ತೆ, what happens in case of metals, okay, the resistivity, what happens to the resistivity in case of metals, when temperature increases, the resistivity also increases, okay, because alpha is positive. In case of alloys, okay, in case of alloys, when temperature increases, in case of metal resistivity, in case of alloys, what happens, slowly, okay, what happens, resistivity increases, but in a very slowly manner, okay, almost linear, okay. For alloy having small value of alpha, resistance does not change too much on increasing temperature ಅಂತ ಹೇಳ್ಬೋದು, okay, but slowly, okay. In case of semiconductors ಏನಾಗುತ್ತೆ, when temperature increases, in case of semiconductors, ಏನಾಗುತ್ತೆ, resistivity decreases. What happens to resistivity decreases, okay. Now here copper is a metal, right, copper is a metal, and alloy ಅಂದ್ರೆ nichrome is a alloy, nichrome, and here semiconductor, okay. In case of copper, in case of X is what, copper here, it is resistivity is increasing, this is copper, right. And Y ಏನಪ್ಪ, Y is nichrome, it is increasing but slowly, okay, nichrome, Y is what, nichrome. Z is what, semiconductor, resistivity decreases, this is nothing but semiconductor, metals are having what, positive temperature coefficient of resistance, therefore if temperature increases, resistivity increases. In case of alloy, alpha is very small, okay, almost equal to 0, therefore resistivity increases but not so much, okay, almost linear irutte. ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ, in case of semiconductor, resistivity decreases, okay. So hope you understood, this is the right answer. X is copper, Y is nichrome, and Z is semiconductor. Next we'll see, given a current wire of non-uniform cross section, okay, this is non-uniform cross section, okay, non-uniform cross section, okay. What happens, only one thing is constant, that is current is always constant, current only, because drift velocity we have seen in the previous problem, that drift velocity depends on what, okay, area of cross section, inversely proportional area of cross section, and then electric field also, okay. What is J is equal to sigma into E, this is what, microscopic form of Ohm's law. And what is J, I by A is equal to sigma, again E is what, inversely proportional to 1 by A, okay. Therefore this is not constant, this is not constant, okay, only current is constant, okay, current always will remain constant. Hope you understood this. Next, the graph between variation of resistance in R is equal to rho L by A, okay. R is proportional to what, 1 by A, that is proportional to what, 1 by pi R square, that is proportional to what, 1 by pi D square by 4, okay. R is proportional to what, 1 by D square, okay, 1 by D square, diameter, okay, where D is what, diameter. Since R is inversely proportional to what, D square, it gives what? Rectangular hyperbola. Where is rectangular hyperbola? Illide nodi. Okay, this is the right answer. Okay, r is what? Proportional to 1 by diameter the whole square. Okay, diameter the whole square. Understood? Therefore it gives what? Rectangular hyperbola. This is the right answer. Okay, the graph between variation of resistance and metal where the function of diameter is rectangular hyperbola. Next one, what is this? An experiment to determine the figure of half deflection method. We have direct formula. G is equal to Rs divided by R minus of S. Rs ಕೊಟ್ಟಿದ್ದಾರಪ್ಪ 5200 ಕೊಟ್ಟಿದ್ದಾರೆ into S ಎಷ್ಟು ಕೊಟ್ಟಿದ್ದಾರಪ್ಪ 90. Okay, divided by 5200 minus 90. G is always approximately equal to S ಇರುತ್ತೆ, S ಇರುತ್ತೆ, which is okay, approximately equal to S irutte. S is how much? 90. You see the answer which is nearer to 90. This one. Okay, 91.6 ohm is the right answer. Even if you neglect 5200 into 90 divided by ಇದು 90 ನೆಗ್ಲೆಕ್ಟ್ ಮಾಡಿದಾಗ 5200 ಅಂತ ಬರೀಬಹುದು. ಅಪ್ರಾಕ್ಸಿಮೇಟ್ಲಿ ಎಷ್ಟಾಗುತ್ತೆ ಇದು? ಅಪ್ರಾಕ್ಸಿಮೇಟ್ಲಿ 90 ಆಗುತ್ತೆ. ದಟ್ ಈಸ್ 91.6 ohm is the right answer. Half deflection method. This is the formula. G is equal to R is divided by R minus of S. Now next problem. What is this? The range of what? Electrical conductivity. The range of electrical conductivity. You just this is resistivity for metals among the following is. You just remember I SAM anta. Okay, what is I SAM? I is what? Insulator. I is what? Insulator. S is what? Semiconductor. Okay, semiconductor. A ಅಂದ್ರೆ ಏನು? alloy. M ಅಂದ್ರೆ metals. Okay, metals. Understood? I SAM. This is resistivity. Always okay, greater than body. I SAM. I S A M resistivity. Conductivity ಏನಾಗುತ್ತೆ? Less than ಇರುತ್ತೆ. I SAM. I S A. Okay. See, for metals resistivity. Okay, resistivity ಎಷ್ಟಿರುತ್ತೆ for metals? Resistivity for metals is what? Is less. Okay, and conductivity for metals is more, which is the right answer here. Okay, where is conductivity more ಇರಬೇಕು. Conductivity more ಎಲ್ಲಿದೆ? Here. Okay, resistivity less ಎಲ್ಲಿದೆ? ಎಲ್ಲಿದೆ? This is the right answer. Like this. Just remember I SAM. Insulator, semiconductor, alloy, metal. First resistivity ಬರೀರಿ. Okay, and then first resistivity ಬರೀರಿ, ಆಮೇಲೆ conductivity ಬರೀರಿ. Okay, this is conductivity. Understood? Conductivity, write down greater than first and then less than. Okay, so this is right answer. For metals, resistivity is less. Okay, and conductivity is more. Okay, ohm meter ಇದು Siemens per meter. Okay, unit ಕೊಟ್ಟಿದ್ದಾರೆ. Next problem. Two similar galvanometers are converted into ammeter. Okay, we have seen this in the previous videos. To convert a galvanometer into a ammeter, what you have to do? You have to connect a shunt, right, in parallel with the galvanometer. Okay, ಎಷ್ಟಾಗುತ್ತಪ್ಪ ಇಲ್ಲಿ? I minus of Ig ಆಗುತ್ತೆ. I minus of Ig. Now I can just G into Ig. Okay, S into, because voltage is same here, S into I minus of Ig. How much current is flowing in S? I minus Ig. Illi G is galvanometer current. Illi I minus of Ig. This is the current to be measured. Okay, now illinda ಏನು ಮಾಡ್ಬೋದು ನಾವು? I can calculate the value of I. Okay, that is I minus of Ig is equal to G Ig by S ಅಂತ ಬರೀಬಹುದು. ಆ್ಯಂಡ್ ಐ ಇಸ್ ಈಕ್ವಲ್ ಟು ಐ ಜಿ ರೈಟ್ ಸೈಡ್ ತಗೊಂಡಾಗ ಐ ಜಿ ಕಾಮನ್ ತಗೊಂಡಾಗ ನಾನು 1 ಪ್ಲಸ್ ಆಫ್ ಜಿ ಬೈ ಎಸ್ ಅಂತ ಬರೀಬೋದು. ಜಿ ಬೈ ಎಸ್ ಮಿಲಿ ಅಮೀಟರ್ನಲ್ಲಿ ಏನಾಗುತ್ತಪ್ಪ, ಇನ್ ಕೇಸ್ ಆಫ್ ಇಫ್ ಐ ಇಸ್ ಮಿಲಿ ಅಮೀಟರ್, ಇಫ್ ಐ ಇಸ್ ಲೆಸ್, ಐ ಲೆಸ್ ಆದರೆ ಎಸ್ ಏನಾಗುತ್ತೆ, ಎಸ್ ಇಸ್ ಮೋರ್. ಓಕೆ, ದಿಸ್ ಈಸ್ ಏನಾಗುತ್ತೆ, ಓಕೆ, ಯು ಹ್ಯಾವ್ ಟು ಮೆಷರ್ ವಾಟ್ milliammeters. Okay, current is less, s ಜಾಸ್ತಿ ಆಗುತ್ತೆ. ಓಕೆ, ದೇರ್ ಫೋರ್ ಕಂಪೇರ್ ಟು ಎಸ್, ಓಕೆ, ಅಮೀಟರ್, ಓಕೆ, ಅಮೀಟರ್, ಓಕೆ, ಅಮೀಟರ್ ಎಸ್, ಅಮೀಟರ್ ಎಸ್ is less than what, is less than, okay, shunt of ammeter is less than what, shunt of what, milliammeter. ಬಿಕಾಸ್ ಅಮೀಟರ್ನಲ್ಲಿ ನಾವು ಕರೆಂಟ್ ಐ ಮೆಜರ್ ಮಾಡೋದು, ಇಲ್ಲಿ ಮಿಲಿ ಆಂಪೇರ್ಸ್ ಮಾಡೋದು. ದಿಸ್ ವಿಲ್ ಬಿ ಇನ್ ವಾಟ್, ಆಂಪೇರ್ಸ್. This will be what, milliamperes. Okay, this will be milliamperes. So if the current is less, S is more. Okay, therefore S is more. S millimeter is greater than what, S ammeter. Therefore ಏನಾಗುತ್ತೆ, ammeter, the shunt resistance of ammeter as come shunt resistance of millimeter ಏನಿರುತ್ತೆ, less ಇರುತ್ತೆ. Less is the right answer. Hope you understand this problem. Okay, this completes your full questions of KCET 2025. Hope you understood. You might have enjoyed this video. Kindly share it with your friends. Okay, kindly share with your friends. Subscribe for my channel, like it, and then ask doubts in the comment box. Thank you one and all. Okay, almost how many problems we have solved, I will just okay, this is the first problem. Okay, 1 2, okay, 3 4 5 6 7 8 problems we have solved. Okay, I wish you all the best. Thank you one and all. Thanks for watching it.